Thank you all for coming. Can you hear me? Hello? That would help. Hello. So this is my second time in Mumbai, obviously. On Asia. So it's really nice to be back in IIT, in the centre, and to see all of you folks, and to see some of my colleagues from Capgemini too. So thank you for coming along. I'm a solutions architect at Capgemini, and I've been working in Drupal for around about 11 years now. I'm mostly working back end, and I do some work on front end, but some work in core, lots of contrib, and lots of work in the overall DevOps system space. So this talk is very much about how do we keep sites up when external services are failing, and these are all parts of our ecosystem. Some of you might only work with a Drupal site that has a database and a file system, and that's it, and it doesn't integrate. But for those of you who do integrate with external services, you probably know how easy it is for those to go down and for those to make your life a world of pain. Before I jump too far into this, I just wanted to say a quick thing about Drupal security, because last Wednesday our team were up late at midnight deploying a very, very urgent patch. Who here has responsibility for managing a Drupal site? Who here is, you're a sysadmin, you're on call, you have to do updates, you're quite a few of you? Okay. So this came out on Wednesday. This was only announced on Monday, so this was a very, very last minute urgent get it patched as soon as possible. So if you haven't patched your site, this announcement came out 4.5 hours after the release. So This is a huge security issue, and you want to patch your site as soon as you can because people are trying to exploit it. What I noticed, though, is that we were there, sitting there, all of our team, watching Twitter, watching Drupal.org, hitting refresh, waiting for this patch to drop. And what do you know? The site went down. Even Drupal.org has outages. So if even the Drupal Association struggles to keep it going at times, we've all got a hell of a challenge ahead. So if you haven't patched, please focus on patching it now because this one is being exploited. So here's a question for you. When was your site last down? So for Drupal.org, it was a couple of days ago. Has anyone had an outage in the last week? Last month? Last year? All of your sites worked absolutely fine. Wow. Well, in that case, I'll just, you don't need me. So yeah, resilience in the face of adversity. Your other systems are going to go down, and we need to think about what do we do to handle that. So I've got a few topics up here. The talk is very much about circuit breakers, which is one particular type of design pattern in this space. So we'll also talk about a few other things in this talk, about the retry pattern, about exponential backup, but all of these talks are about resilience for third-party services. So I put up a couple of examples here. So in a Drupal site, you've got your DB, a file system, and let's face it, if the database goes down, there's nothing you can do. A Drupal site will not work without a database. So all of these ideas about resilience and exponential backup and so on, they don't really apply to things that your site has an absolute dependency on. You can't do anything to prevent your site going down if an essential service stops working. But the thing is, usually you manage these yourself, right? So these are on your own hardware, whether you're running on Amazon or whatever. These are running on the same instances. So actually, if your database server has gone down, probably your entire infra has gone down, so you need to jump in. That's a different problem space to have. These ones on the end, it's fair to say that in most sites, they're not essential. So if your Solr server goes down, well, your search breaks. I mean, that's not great, but people can still use the site, unless your entire site is Solr, and that's something else. But yeah, if Solr goes down, you can still use your site. If you use ClamAV for scanning, for antivirus, for people who upload files, then if your antivirus server goes down, well, you can still run the site, but people can't add content. Or they can add content, but it won't be scanned. That's a risk you may want to take. If you're using payment gateways, maybe people can still use your shopping cart, people can put things in, people can process it, you just can't take payment. Now, those are things where you're relying on an external service. Quite often, these are services provided by outside providers, either as a SaaS product or a PaaS product. Acquia have their own Solr ecosystem. You can go to Acquia for Solr. A number of other companies do that sort of thing. So these are things that are quite often outside of your ecosystem and outside of your control. And this is where these challenges come to play. Now, this is also a user experience problem. If you have a Solr system and someone goes to search for your site, and they want to search sessions on the Drupal Camera and Buy site, but they type in the keyword that they're searching for, maybe they're searching for decoupled. And the first thing that happens, and this is the first little incremental point towards resilience, is a timeout. Now, quite often these are set to 30 seconds. That's a long time to be sitting at your desk in front of your computer, and you're going, come on, come on. Why is it taking so long? So your timeouts are important. and your timeouts need to reflect how long it typically takes. If your Solr server normally takes a second or 2 seconds to respond, there's no point in setting your timeout to 30 seconds, because you know if it hasn't responded, if it's normally 1 to 2, then maybe it's a little bit slow, and maybe it takes 5. If it takes 30, the user experience is hammered, and you basically spent about 25 seconds waiting for something where you already knew it had failed. So the first step is looking at what does that timeout look like? What's an appropriate period of time to let a user wait? And that's going to change depending on your system and depending on the site you operate. User experience will tell us that people will wait, I don't know, maybe 7 seconds on a typical website before they go off. But then if they're completing a tax return and have to do the tax return by law by a certain day, they'll keep on going if it's 10 minutes, 20 minutes. So the degree, the timeout that you put needs to be proportionate to the activity the user is doing. And you know your users a lot better than I do. So I can't sit here and say, you must do 30 seconds, you must do 5 minutes. You need to choose a value that suits your site and the work that you're doing. And all sorts of things can cause problems. So the common one is just that the external service goes down. That tends to be the standard issue outage. But there's a very complex set of connections. So even if it's just from one AWS region to another, or from an AWS service to Azure, these are big broad links, but sometimes you might find latency is an issue. You might find DNS is an issue. Misconfigured firewalls or IP table rules. All of these sorts of things can have a failure. They can stop you connecting to your external service. And actually, HTTPS certificate expiry is one of the ones that I haven't put up there, and I probably should add that, because that's quite a lot. That's one that won't ever resolve itself. You can keep on trying and retrying and retrying, but until someone goes and creates a new SSL certificate, that ain't going to change. So you've got lots of different failure causes and lots of different ways you can handle that, some of which you handle in software and some of which you have to handle externally. You see, this is a failure mode right here. I keep on retrying. Yes, Solr is one of the best tools I have ever found for search. So,
do you suggest any monitoring for that to see how the response is coming? Any open source monitoring?
Yeah, so tools like Nagios is a very common one. You'll find lots of different tools depending on the platform and the infra that you're using. What I'd like to show you is some ways that you can handle it where, without the monitoring side, you can have a response in Drupal that doesn't need a sysadmin to intervene and to give you a little bit more resilience for the site, even if the service is down.
Does it, instead of giving the content searching, can it go for the log searching also? The access and everything?
Yeah, there's lots of different fallbacks that you can choose. So when you've got a failure, you can categorize them as short, medium, and permanent. So an example of a short-term one is rate limiting, and you'll find a lot of third-party services do implement that. Or another one is that the third-party service is under a DDoS attack, so it's just a little bit overwhelmed. And these are the sorts of things that can be. Rate limiting is a really short time. So if it's a rate limiting issue, you might want to retry that request after 10 seconds, 10 milliseconds, 20 milliseconds, and have a really short period of time, short enough that even the user won't notice. A transient problem that's medium term might be a DDoS that's going to go on for a couple of hours, or it might be that the server has just crashed, and then someone's going to wake the person on the DevOps team up, they've got to log in, they've got to have a coffee. It's going to be a couple of hours before that system is back. You might find it's a permanent problem, like a username and password that's expired or has been changed. And again, for those issues, there's no point in retrying and retrying and retrying, because your password isn't going to magically correct itself. So these are different types of failures that get treated in different ways. Again, I can't stand here and tell you how to correct those failures or even how to identify them. These are about you understanding your systems, looking at it from a future planning point of view. How can I categorize this? You know, for example, that Solar is going to give you an invalid username and password message. So you know at that point, if you receive that in your code, you need to find a way of saying, password is invalid, shut the service off, don't even retry. And sure, you want some alerting in all of that. You want a mechanism where you tell the team, you send them an email, the username and password is expired, you need to fix this. But until that's fixed, you want fixing it to be a manual process. And again, when it comes to timeouts, if it's a short-term thing, you can try again in a few milliseconds. If it's a medium-term thing, maybe you want to time out in minutes, maybe it's 5 minutes, and we'll have a look at what those patterns look like longer term if an outage continues. And then others probably don't want to retry at all. So this is all about proactively managing an outage. Circuit breakers have 3 states. By default, the circuit is closed. Every request you want to make to Solar goes to Solar, comes back. And that's a good place to be in. So, you're happy back. When you detect a failure, what happens is that after a certain amount of failures, the circuit switches to open. So every time you want to make a request to Solar, your circuit breaker doesn't even pass the message on to the service because you'll have all of the timeouts and all of the delays. The circuit breaker just says no response. So instead of waiting for that 20-second timeout or 30-second timeout, you get an immediate answer, this service is not available. And you can also do some detection in there. So if you know the search service is down, maybe you hide the block on the homepage so that people can't even access it. Maybe you replace that with a message to say, search is unavailable, come back later. This is all about understanding the state of your system and communicating that to the user and to the system so that you don't slow it down. One of those really important things about the timeouts is that when you make a request to Solar and you're waiting for this 30-second timeout, throughout that 30 seconds, you've got that PHP thread that's open in a locked wait state, it's just waiting for a synchronous response. Now, if you imagine a lot of users on the site, and all of these PHP threads that would normally complete within a couple of seconds are waiting in 30 seconds, it doesn't take long for a third-party outage to bring your entire site down. So that's where it's really important to understand what the normal behavior is and to try it out in different states so that you can prevent, you can close or you can open the circuit and shut the service down and keep your own site going. So this is how it would normally work. You'd start off, you would choose yourself a threshold for Solar, whether it's, this threshold is the number of failures. Maybe it's 1, maybe it's 2, maybe it's 5. So for a search service like Solar, I would choose maybe 5 failures. I would also look at how good the existing system is, how frequently it fails, how many people are simultaneously trying the service. But in my experience, 5 is a reasonable number for Solar. And every time you get a failure, the circuit breaker increments the record, the number of failures it's had. And it reaches its threshold and disables the service. So we are now in an open circuit state. And we leave that circuit in an open circuit state. That's 5 minutes. Got a good period of time where the search is totally unavailable and we don't even try the search service. Now again, that 5 minutes is just something that I feel is a good number for Solar, but you might have a different view on the way you use the site and you might have a different view on different services. Once that 5 minutes is up, you don't go straight back to open. You go back to a state that's called half open, where it tries a connection. And if it succeeds, then it resets the circuit breaker, your count of errors goes back to 0, and you're back to a closed circuit. Everything's good. However, if it doesn't work, then you want to use something called exponential backoff. And the concept of exponential backup is the idea that when you are hammering your sites, when you're hammering a service that's maybe a little bit underwater, you don't want to keep on retrying, because the more retries you do, you might be making the problem worse, especially if it's coming to rate limiting, where you know you've sent a request and that's been rate limited, so it's been cancelled. So you send another one straight away. And you're like, well, that one's really not going to work. And a third one is really, really not going to work. So the point of rate limiting or exponential backup is to tone down the amount of traffic you send to an external service. So a pause of 5 minutes, for example, on Solar, switch to half open, service fails again, so you increment your failure count again, so that's gone up to 4. And you double the duration of your open circuit. So the first time it's out for 5 minutes, the next time it's out for 10 minutes, 20 minutes, 40 minutes, and these are all proportional, so you want to vary them, maybe it's a data request, these want to be milliseconds instead of seconds. But the principle is that as you go through this process, you keep on increasing the amount of time that the system is in this shutdown state. There's lots of things to consider here, whether you're looking at processes that are synchronous, and both from a technical capability, but also from a user experience capability. So from a technical capability, a lot of things are synced. Solar, for example, is a synchronous process, but it's also synchronous to the user. Now, the user is going to sit there waiting for a response until Solar finishes. For something that's async, a good example is if a user wants to upload their CV to a recruitment site. Now, you know you want to virus scan everything coming into your system. So by default, the ClamAV service will virus scan on demand everything that comes in. If the virus scanner is down, then it's got a choice. You can either retry in a second, but the user is sitting there waiting for the response, waiting to confirm that their CV has been uploaded. In this case, the only change to an infected virus is that you don't want anyone else to download it. So you have got a choice here. You can accept the file, you can maybe quarantine it, put it somewhere that no one can access, and add it to a queue for virus scanning later on. So actually, you've got some async processes where, even though the failure is long-term, the user experience, you just tell the user, your file has been uploaded and will be reviewed shortly. They don't need to know that it's going to this virus scanning thing. They don't even need to be aware that your virus scanner is down. So you've got a failure that has no impact on the user experience whatsoever. And again, these are the sorts of considerations that I look at when I'm looking at how do I set up a circuit breaker, what's the appropriate pattern. How long does it take? How often does it fail? What kind of failures? Error messages are really good ones because you'll know, like the example of username and password failure. You know that that's not something you can ever retry. You know that you need someone to manually intervene before that problem is fixed. So very much a question of looking, documenting the external services that you use, understanding what is the best, most suitable approach for those. A lot of these examples come from Netflix. Netflix is a really, really good resource for all of this. So, are you familiar with the Chaos Monkey? Anyone heard of the Chaos Monkey? Chaos Monkey was one of Netflix's first system resources for resilience. And what Chaos Monkey does, it's a little piece of software that runs on AWS. All of Netflix's stack is AWS. And Chaos Monkey goes around shutting down AWS instances. And, can you imagine doing that in your own software, on your own site? You imagine having a bot that went off and just, I don't like that server, off. And the best part is that it didn't even do it in pre-prod, it did this in production. Try having that discussion with your boss. So it's a really good way of detecting and addressing issues. So a lot of these things, so the Hystrix library came out of Netflix's effort to improve resilience. And there is a PHP port out there for Hystrix. There's also a circuit breaker for Symfony that fits quite nicely into Drupal 8. One of the challenges is there is very little on a library basis for Drupal 7, and to be honest, for Drupal 8, it's not really a pattern that we see used in many places. And that's a challenge for all of us, because without a library that we can start dropping in, what we see is some people are manually writing circuit breaking patterns into every single external service that they use, which makes it really hard to manage, and it means that you've got lots of people doing different things, and you have to write it again and again and again for every single one. And in some cases, it doesn't even exist. You know, if you've gone and used the Contrib module, then they haven't written it, who's going to? So I think we've got a challenge to step up as a community to look at this space. There are good examples where we could create a standard pattern. So Drupal HTTP request, we could intercept all of those. We could apply the circuit breaker rules by domain. Say, okay, so this site is out, so we won't send any requests to that for a period of time. And we could, you know, we could manage it all within Drupal. We don't have that at the moment. So this is something I'd like us to see addressing, evolving. The other one is Charles Proxy, which is a desktop application that you can use to simulate a lot of these failures yourself. Charles Proxy will let you simulate latency, slow connections. Unfortunately, it's not quite an open source app. It is a paid for app, but it is very good. And on the subject of Chaos Monkeys, they also have Chaos Gorilla, which will switch off an entire AWS availability zone. If you want to check out whether or not you're HA ready, well, give that one a try. So that's all the slides I've got on the topic. Does anyone have any questions that they'd like to add? No questions? So I'll show you a couple of the resources that I've been looking at and I use regularly. Yeah?
So, normally, how can we determine what kind of patterns? So, you need the kind of rule report that it might in the sense of failure we will be facing our site. So, is there any such tool which gives this kind of pattern analysis and provide analytical output kind of?
So I'm not familiar with any tool that allows us to choose, you know, to recommend a pattern. Much of this is based on an understanding of your system. And a lot of this is about conceptually what could the issues be, which means that, you know, if for example, you wanted to analyze Solar, you can try and load test it, you can try and take it out. But you really have to sit down and deliberately think through what are the possible failure modes. So if it's a Solar connection, it can fail on network, it can fail on DNS, it can fail because the server is out, it can fail on credentials, it can fail because the version of Solar Query that you're using doesn't match. And it's about putting the appropriate error handling in place. So there's no clear answer. There's a question of sitting down, reading through the documentation, saying, okay, so these particular errors tell me that this particular thing won't ever work. So don't retry. This particular behavior and the site not responding, for example, is a good one. A site not responding tells you, well, it could potentially be back up in a couple of minutes, but you have to decide what that number looks like based on your understanding of the system. So if it's a Solar server that you run, and you know that, say, if it encounters an issue that it's got a service system that will reboot the server and bring it back up, you know that that reboot cycle is going to take 1 minute 40 seconds. Therefore, an outage of 2 minutes is an appropriate place to set your threshold. If you know it's an external service, then you're dependent on the information that they provide you. So we do a lot of work with Acquia. We know what Acquia's service level agreements are. We know that if System X goes down, I can expect it to be up within an hour. So actually, even though I know it's back up within an hour, I set the thresholds on those to 10 minutes because actually it may be open quicker. And if I switch to that half open state in 10 minutes time, that's not a bad thing, and I'll let one test there. And if it's 10 minutes and it's not up, well, the next one will be 20 minutes and 40. So it might take 3 cycles of that retry, but it's all about looking at your ecosystem and deciding for yourself which numbers make sense. Does that answer your question?
Yeah.
Thank you.
How is it?
How hard is it to integrate these tools into your site? Hard. Actually, yeah, in practice, so the tooling that we looked at, and let me put that slide back up again. So if I look at some of those tools, yes, the Hystrix library is written for Java, and to a certain extent, Java is more suited to some of these patterns than PHP because they've got a lot of Spring framework and so on. So the Symfony bundle is a pretty good example, but the tooling isn't there within Drupal. Even though D8 is based on Symfony, the tooling isn't there yet to simply implement it. So at the moment, what I've been doing is writing this on a case-by-case basis. So I'll write it on the Solr integration function that I've got. I'll write it onto the ClamAV integration that I've got. And in all honesty, it's pretty primitive. The libraries that are out there do all sorts of things about measuring thresholds, configuration, retry patterns. What I do at the moment is very simple. If it has a certain number of failures, cut off, and cut off for a period of time that doubles. That's the simplest implementation of a circuit breaker pattern that you can do. Other ones like these libraries, they'll have patterns where, if you've got this, if you reach 5 failures, and then you switch to open circuit, when it goes to half open and detects a success, it doesn't totally reset the circuit breaker because it might be one off that succeeded. And therefore, once the next request fails, you don't maybe want to wait until it stacks up to your threshold before disabling again. It's very much looking at the ratio of successes to failures. So a lot of these libraries have got a lot more advanced capability, but that doesn't exist in the Drupal ecosystem yet. This is maybe one of the challenges on me over the next year, to look at what can be done to develop Contra modules that implement these patterns and makes it a lot easier for everyone. But it's also about the whole community and everyone in this room. If you're focused on back-end development, anyone who's in back-end development can help write these modules. Anyone who's not a developer can help write the documentation for these modules. Anyone who's in test can help write the test processes for these. So the whole community can help, and I think there is a gap here that we do want to fill because it's in a lot of other frameworks and it's in a lot of other places. And when you see Drupal.org having an outage, well, it's maybe a message that we can do better and the tools are out there, we're just not making as good use of them as possible. Does that answer your question? Apologies that the answer is it's really easy, and here's an example. Maybe next year. Any other questions? Yes. Yeah, so Drupal core security is really good. Drupal, as it stands today, the latest version of Drupal 7 and the latest Drupal version of Drupal 8 is secure. There's actually been a lot of press, especially with these recent incidents that we saw. And there's a clear message that actually what we're doing is we're recognizing the fact that there is a vulnerability. We've got a very well-structured process for addressing those vulnerabilities and a well-structured process for communicating those to the people who use and manage the system so that they can apply the updates in a managed, thoughtful, known way. The reality is that when you look at competing CMSs that don't have a security team and don't have a security release process, that's not because they're not vulnerable. It's because the vulnerabilities are staying hidden. So I think although it got a lot of press, what happened over the last week is a really good demonstration of the work that the security team have done. And every member of the security team is a volunteer, so they're putting in their own time and effort to help keep everything safe. And I thought the communication process was really good. It is a challenge for us because, unfortunately, some of the release cycles are more scaled to UK hours and to USA hours. So the release came out between 4 to 6 p.m. UK time, which I think is between 11 and 1 on the East Coast, 9 to 11. Which unfortunately meant that, you know, some of the team I work with here in Mumbai were up at midnight patching. So it's difficult and unsociable hours for what we do, which is the best place to be in. If within your teams you create automatic patch management, if you've got a process where actually you can click update and it'll just apply the patch to your code base and create a new release tag. If you've got simple one-click deployment processes, all of these good CI things are things that will make your job a lot easier and make it, you know, it might still be midnight, but I'd much rather be there for 2 minutes of midnight than 20 minutes of midnight or 2 hours of midnight rolling out changes. Does that answer your question? Anyone else? Let me wrap up very quickly with a quick look at that one. Where's my Firefox? So these are just a few of the resources that I use to manage these things. And let me see if I can zoom that out. No? Okay, apologies. It's the screen's not quite scaled for these. So dzone is one where it's got lots of articles about these particular topics, and it'll go in more in depth and give you some code examples of addressing those. And the Microsoft Azure documentation. Hang on. Let me see if I can get this new full screen. There we go. That's better. You can see down here, you've got a list of all sorts of different topics, you know, so queue-based load leveling, priority queues, making things like maybe your antivirus scanner queue is the top priority in your list, whilst, you know, rebuilding XML sitemaps might be a low priority queue item. All of these things are, again, they're very much on the top of resiliency, prioritizing the important things, making sure that the things that aren't important aren't forgotten. But if the service is down, you can keep going. So these are some of the tools that I use on a lot of projects. And you can see lots of resources in here. So although some of these on Microsoft Azure stack don't apply to Drupal, the principles and the design patterns can be used on any software you write. So 2 really useful resources there. Any questions or comments? In that case, thank you very much. Oh.
Regarding this distributed denial of service, do we separate at server level to firewall? Or does Drupal have any motivation tools for that?
Sorry, for
DDoS.
DDoS. The trouble with DDoS attacks is that there are failure modes at all sorts of levels. DNS is a good one, network bandwidth is a good one. So Drupal does have some really, really primitive ways of handling lots of traffic, whether that's DDoS or just higher traffic than normal. So within blocks, for example, there's a throttling mechanism that you can use to decide which blocks you can display or not display. Unfortunately, yeah, it's really primitive and there isn't a great deal you can do. For DDoS mitigation, we almost entirely use Cloudflare in the big things. It's got WAF protection and general CDN. And the other nice component of CDN is that we do cache almost all of the content. So even if our backend goes down, there are some cases where it's still available. And there are lots of other CDNs and DDoS tools. But yeah, you'll struggle to do that in Drupal. And actually, even if you're looking at your AWS ecosystem, for example, putting a firewall in there will help, but Cloudflare tends to be, or ACDN tends to be the most cost-effective solution. Anything else? In that case, So we've got 15 minutes until the next session. The next session in here is about Docker. You've also got topics on Drupal 8 and decoupling. You've got maintaining team health whilst you're managing multiple projects, which I suspect apply to many people in this room, and open design for open community. So Drupal 8 plugin API. That's everything from me. Thank you very much.